Hi everyone. If you missed class on Monday or Tuesday of this week, our first week back after Christmas break or winter break, then this is the activity that we did in class and in small groups. I'm going to run through it with you real quick, and then you can go and complete this on your own and get it turned in. All right, so a little background information. We have two major categories or classes of compounds that we usually see in chemistry. These compounds are either ionic or covalent. All right, and so let me give you some examples here. I know my video is pretty small down in the corner, but if you look there, you can see I've got a jar here. This contains water, and water is made of a compound that is covalently bonded together. And so here you can see a little molecule of water. If you have a lot of those, then you have liquid water here at this temperature. On the other hand, if you have an ionic substance, they go together a little bit differently. They tend to form crystals, and here you can see this is sodium chloride, which would be table salt, but the sodium and the chlorine ions stack together to form crystals, and you can see I've got a little fluorite crystal here, part of my rock collection. And if you're into collecting rocks and you like to collect crystals, then you're probably collecting ionic substances. All right, so the concepts describing how these compounds are held together, which is called bonding, can be learned as we progress through our studies. What does that mean? It means we're learning the basics right now. When you go to biology, you're going to learn a little bit more, specifically how it applies to life. And when you go to chemistry, you're going to learn even more. And if you go on to college, there's still more to learn about how these substances are held together and how they interact. But before you understand those concepts, you have to be able to quickly identify a compound. So those are the formulas, as either ionic or covalent. In other words, your ability to classify compounds will guide how you think about these bigger ideas later, all right? So what we're going to do today is we're going to take a look at some compounds, and these are formulas, right? Chemical formulas of compounds. And we're going to try to figure out what makes these compounds ionic, right? Because in this column, we have ionic at the top. So what is it about these that they have in common that makes them ionic? And what about these makes them covalent? Can we find the pattern that will let us quickly look at any chemical formula and decide, hey, that's an ionic compound or that's a covalent compound, so that we then know how to think about that compound? All right, so down here, this is just about reading the chart. The compound ZnCl2, zinc chloride, is considered to be a blank compound. Find ZnCl2 in the table above, and then type in here whether or not it is ionic or covalent. All right, you're going to do the same thing below for number 2, the compound that contains nitrogen and oxygen. So find the compound above that contains those two elements and determine whether it is ionic or covalent based on where it is in the table. Next, we have an activity. Well, before we go to the activity, let's look at number 3. Does this classification, so ionic or covalent, does it seem to be based on how many atoms of each element are represented in the formula? Well, how do we know how many atoms? That's this subscript here, right? So subscripts tell us how many atoms. This little 2 tells us 2 chlorine atoms. This little 2 tells us 2 sodium atoms, right? And it looks like subscripts exist in both categories. We have some in the ionic side, we have subscripts in the covalent side. So do you think subscripts are the thing that we're looking for to tell us whether or not they're ionic or covalent? All right, so think about that before you answer. Number 4, drag these element symbols. So these element symbols came from this list of compounds. I basically put an element symbol on here for each of the elements participating in all of these compounds. There's 10 of them. All right, you can see some of them are used more than once. Here we have oxygen. Oxygen is used in a few places, and so is chlorine. All right, and you're going to drag these things. You can click on them and move them around. You're going to drag them to where they belong in the periodic table. And you might be asking, well, how do I know where they belong? You can click on this link and you'll get a digital copy of the periodic table. In fact, you should bookmark that. Okay, so I strongly recommend you open this and then add a bookmark to this periodic table to your bookmarks bar. That way, anytime you need to refer back to a periodic table, you have one handy, all right? So look at your periodic table, figure out where all of these elements go, and then drag them into the correct location. All right, after you have dragged them into the correct location, you're going to go back to this chart and think about if you see any patterns. Do you see any patterns between the elements and their placement on the periodic table versus particular elements that make up either one of these types of compounds? All right, number 5 is where you talk about any patterns that you were able to find, okay? And if you're struggling to find a pattern, I would say, I will give you this hint. It does not have anything to do with the fact that most of these elements are single letters. Okay, that was a coincidence, all right? This one here is not a single letter, but the rest of these are. That is just a coincidence. These could be other elements that have more letters. Okay, so that is not it. That is not the one we're looking for. All right, but it does have to do with the placement of these elements in particular on the periodic table. Okay, if you still can't figure it out, my recommendation is to watch the video on ionic bonding that was posted after the practice assignment. Okay, watch that video, then come back and finish this. All right, you should be able to figure out what the pattern is by watching that video, because I know it says it pretty early on. All right. Once you have that pattern, you're going to be able to classify each one of these compounds as either ionic or covalent. And it really does have to do with which elements make up the compound. All right. Okay, so that's the assignment. If you are struggling with this and you've watched the video and you still don't know how to do it, send me an email and we will work on it together. All right. See you next time.